Welcome to my channel. This is Franco Pantaleon. In this video, we'll take up circles and triangles. We'll focus on determining the following: the sector area, the arc length, and for triangles, we'll focus on determining perimeter, area, angles, and side lengths. So, we have here two very important formulas for determining the sector area and the arc length formula. Now, suppose you have this sector area, the shaded area A, and we have radius R with angle theta. We will simply use this formula: A equals to 1/2 theta R squared. Now take note here that the angle theta must be expressed in terms of radians. And if we wanted to determine the arc length S, we will simply use this formula: S is equals to theta R. Again, the angle should be expressed in terms of radians. These are the two very important formulas for determining the sector area and arc length. Now, sometimes it is very important that you should be able to convert from radians to degrees or from degrees to radians. Now, if you wanted to convert radians to degrees, you simply multiply the angle measured by 180 degrees over pi. So we have this corresponding factor. We use this factor to convert from radians to degrees, and we will use this factor to convert from degrees to radians. Now let us have some illustrative example. Now suppose you have 90 degrees and you wanted to convert this angle into radians. So we simply multiply R. We have 90, and our factor to convert from degrees to radians is times pi over 180. So this is simply equal to pi over 2, which gives you this value here. Now let's have another example. Now, if you wanted to convert 150 degrees into radians, again, we simply multiply that into pi over 180. So we have 5 pi over 6. Again, this gives you these values here. Okay, from 150 degrees to radians, we have 5 over 6 radians. Now, let's have another example converting from radians to degrees. Okay, let's just take, suppose we have pi over 4 radians, and if we wanted to convert this into degrees, so we simply multiply that with our factor 180 degrees over pi, which gives us 180 divided by 4, which is 45 degrees, which gives you this answer. Okay, so let's move on to the next topic. Now, if you have right triangles, we can apply the Pythagorean Theorem. You have your a squared plus b squared equals to c squared. So we can apply this Pythagorean Theorem to determine the value of any unknown. So suppose you have, this is your c, and this is your a, and this could be your b. Now, if you wanted to determine sine theta, by the way, so that it will be easy for us, we will simply use this mnemonic formula here. We have SOHCAHTOA, which stands for, to determine the sine, we have SO, opposite over the hypotenuse. For cosine, we have adjacent over hypotenuse, and we have for tangent, we have opposite over adjacent. So if we wanted to determine sine theta, then if this is our opposite, we have B, then we have our sine theta would be equal to B over hypotenuse is C. And if we wanted to determine cosine theta, our adjacent is A, our hypotenuse is C. And if we wanted to determine tan theta, then our opposite is B and our adjacent is A. Now, to determine the area, we simply follow this formula. We have 1/2 B each for determining the area of our triangle. So, let's move on to the next topic. Now, if we have a triangle which has two sides AB with angle C between sides A and B, then we can use this formula. We have this area is equals to 1/2 AB sine C. So we have here two sides with one included angle. Then we can use this formula to determine the area of this triangle. Now, another very useful formula is the Heron's formula. If your triangle have side lengths A, B, and C, then you can directly determine the area of your triangle if you know the side lengths A, B, C. So it is given by this formula here. Now, S stands for your semi-perimeter. Now, it is determined by this equation. We have A plus B plus C over all over 2. Once you have determined your S, then you can directly determine the area using this Heron's formula. Okay, another very important tools or formulas you can use when dealing with triangles are the law of sines and the law of cosines. For the law of sines, we have sine A over A is equals to sine B over B equals to sine C over C, where your A, B, and C corresponds to the angles, and your variables, small letter A, B, C, corresponds to the side lengths. Now take note that this corresponds to, this angle corresponds to this side length here, and this angle B also facing this side length B, and this angle C is facing this side length C. Now this is a very, very important tool or formula when you wanted to directly determine the values for angles or for side lengths. Now, another very useful formula would be the cosine law of cosines, which is given by this formula. So we have c squared is equals to a squared plus b squared minus 2ab cosine of c. Now take note that the pattern is just simply repeating. So if you have b squared is equals to a squared plus c squared minus 2ac times cosine of b, and you have here another equation. Take note that the pattern is just repeating. So this should be this, and this should be seen here, and this should be in your equation. Okay, now to sum up, if you wanted to determine the arc length, or you wanted to determine the perimeter, you simply use this formula for sector. You have S equals to theta r, where your theta is in radians. And to determine the area, you use this formula here. We have A equals to 1/2 theta r squared, where your theta is in, again, radians. Now, for right triangles, then you'll be able to determine the perimeter by simply adding all the sides. And the formula is simply equals to, for area equals to 1/2 BH. And to determine the angles, then you can use the SOHCAHTOA. Now for non-right triangles, to determine the perimeter, we have similar formula. Then another very useful formula, we have side with two sides with an included angle. You can also use this formula. And by the way, if you can simply remember this formula, and you can use this, which still gives you this formula, will still give you this result once you have a right triangle, because your sine of 90 degrees is simply equal to 1, which gives you this value here. So it would be better to simply remember this formula. And for this Heron's formula, and for the law of sines, and for the law of cosines, these are usually the tools or the formulas you need to use with solving problems involving circles and triangles. Okay, so let us have an illustrative example. Now, given the radius of the circle R is equals to 10, determine the area and the arc length for A, theta equals to 180 degrees, and B, theta equals to 360 degrees. So, we are required to determine the area and arc length for these corresponding values of our theta. So, we will have two columns to determine the corresponding area, where the area is equals to 1/2 theta r squared. And for the arc length, we have theta r. When theta equals to 180 degrees. And by the way, when theta is equals to 180 degrees, if we convert it into radians, this is simply equal to pi. And when we have theta equals to 360 degrees, or theta is equals to 2 pi. Okay, so our area, when we have theta equals to pi, we have 1/2 times theta is equals to pi r squared, and the corresponding perimeter is equal to, now the arc length is equals to theta, which is equal to pi times r. And by the way, the value for this, when r is equals to 10, this will give us the value of, when r equals to 10, this gives us for our arc length S. This, when R is equals to 10, this gives us a value of 31.416. Now, when our theta is equals to 360 degrees or 2 pi, again, we will use this formula. We have 1/2 pi or 2 pi times r squared, which is simply equal to pi r squared. Take note, this is the area of our circle. This formula for full circle, when theta equals to 3, one complete revolution equals to 360 degrees. We have one full circle. We have, and the area for our circle is simply equal to pi r squared. When r is equals to 10, this will give us a value of 314.16. Take note, this formula is very useful because we'll be able to determine the area for different sectors and for the full circle. Now, when our angle is 360 degrees, then our theta here is 2 pi, which is equals to, and our S is simply equal to 2 pi r. Again, this is the perimeter of our circle. Okay, so if you know this formula, then you'll be able to solve for any area for any sector, including the circle. And likewise, you'll be able to solve for the arc length and the full perimeter of your circle. Now, let's have another illustrative example. Determine the following: the area of the triangle ABC given this figure, and the angles A, B, and C. So if you notice, we are given the 3 side lengths. We have 10, 12, and 14. So, given the 3 sides, we can use the Heron's formula. So, our formula for letter A, the Heron's formula, the area is equal to the square root of S times S minus A times S minus B times S minus C. Okay, the square root of this value here. And our S, take note that our S is simply equal to A plus B plus C over 2, which is equal to, we have 10 plus 12 plus 14 over 2, which gives us a value of S equal to 18. Okay, so our S, okay, S minus A, so our A here is, this is our B, and this is our small letter C equals to 14, and B is equals to 12. So we have S minus A, 18 minus 10, we have 8. S minus B, we have 18 minus 12, we have 6. And S minus C, 18 minus 14, we have 4. So we will simply substitute these values here. So we have our area equal to, we have 18 times 8 times 6 times 4, and our area is equals to 58.5 79. This is our answer for letter A. The area should be 58.79 square units. And for letter B, we wanted to determine the angles A, B, and C. Now take note, guys, that we know the three sides, and we can use the law of cosines to determine the any unknown angle. So in this case, we can use our law of cosine. C squared is equals to A squared plus B squared minus 2AB cosine of C. So take note that your C, A, and B are all known, and the only unknown is your C. Then we'll be able to solve for the angle C. So we have this case, we have 2AB cosine C is simply equal to A squared plus B squared minus C squared. And we have cosine of C is equals to A squared plus B squared minus C squared over 2AB. Now with this equation, we will be able to determine our angle C. So substituting the values, we have cosine of C equal to our A is 10 squared plus our B is 12 squared minus 14 squared over 2 times 10 times 12. This gives us cosine C equals to 0.2. And solving for the value of our angle C gives us 78.46 degrees. Okay, so our C should be 78.46 degrees. So this should be the angle for C. Now, since we already have our angle C, we can now use our sine law to determine our any angle A or B. So in this case, we can use the sine law. We have sine A over A is simply equal to sine of C over C equals to sine B over B. So we can now solve for any angle. In this case, probably we will solve for our angle A. So we have sine A over A, which is 10, is equals to sine of 78.46 over C is 14. So solving for A, we can have our angle A would be 44.41 degrees. So our A is 44.41 degrees. Now, of course, we can still use the sine law to solve for our angle B. However, it would be more direct to add these angles and subtract that from 180 degrees, such that we can determine directly the angle B. 180 degrees minus 44.41 plus 78.46. Our B should be equal to 57.13 degrees. Okay, so in this illustrative example, we have solved for the area of our triangle ABC using the Heron's formula, and we also use the law of cosines as well as the law of sines to determine the corresponding sides and angles. Now, okay, as a final check, we will try to check with the formula, the SAS formula. Our SAS formula is equal to 1/2 AB sine B. Pwede. Okay, 1/2 AB sine C. Okay, we'll use this formula, sine C rather. Okay, so we have, let's try to see if we will still have the same result. So we have 1/2 A, which is 10, B is 12, and sine of 78.46 degrees. So our answer is, computing for these values, with the result of this operation, we have 58.79 square units. Again, guys, we still have the same result in computing for our area. Okay, so I hope you learned. If you like the content of this video, click like, subscribe, and please share. Thank you.